As we saw, MLPs can approximate almost any function, and the tasks we want the network to perform can be thought of as functions. However, we often don't know the exact details of the function we're trying to mimic. This is because for real-world tasks such as image and speech recognition, these functions are complex and cannot be simply defined with a known formula. In other words, we don't know the value of the function for every possible data point. So the first step to training a network is to collect a set of samples for which we know the values of the function. For every piece of data, like an image or speech recording, we collect its corresponding target label or output. Think of it as pairing an image with its category or a speech clip with its transcription. These paired samples become the training data for our MLP to learn from. Let's take a closer look at the target outputs for our data set. For regression tasks, things are relatively straightforward. Regression involves predicting continuous values, so the output of our data set would typically be the expected numerical values themselves. For example, if we're building a model to predict house prices based on various features, the target outputs would be the actual prices of the houses in the training data. Classification tasks, on the other hand, require a different approach. Here we are aiming to categorize data into distinct classes. However, neural networks fundamentally operate on numbers, not textual or categorical labels. So simply having labels like apple, banana, cherry wouldn't suffice. Instead, the textual labels need to be converted into a format that the network can work with. This is where one-hot encoding comes into play. Using our fruit example, instead of the textual labels, we'd represent each fruit as a binary vector of zeros and ones. In this format, each position in the vector corresponds to a specific fruit category. A 1 denotes the presence of that category for a given data point, while 0 indicates its absence. By converting our labels into this numeric format, we ensure that our network can effectively learn to classify data points into the correct categories. This was a quick take from LLM Chronicles. If you enjoyed this snippet and want to dive deeper into the world of deep learning and large language models, just check the full episode in the description below. Don't forget to like and subscribe to support the channel and get notified of all new content.